Hello students, so let's try to solve one more problem from Introduction of Quantum Mechanics written by David J. Griffith. This is really wonderful problem and this is again from the harmonic oscillator. So it is a very nice problem and you have to apply postulates in a very efficient manner into this particular problem. So this is problem number 2.13. In this problem it is given a particle in harmonic oscillator potential start out in a state. So at t is equal to 0, a state is given and this is nothing but the superposition of ground state and first accelerated state. And A is the unknown constant which is actually normalization constant. So we have to find the suitable value of A. And then construct psi xt. So means we have to just construct how my psi xt can be written, and then we have to also construct the probability density after time t. So this is given, and then we have to calculate the average value of x and average value of momentum, and we have to just find on the psi xt state. So this is very interesting. And the next problem is that we have to also find the if energy is going to measure, then what will be measurement and what will be associated probability. And in between, it is also said that just try to check the Ehrenfest theorem and just try to see how it is very close to the classical system and something like this. So let's try to go for step by step to each and everything. So obviously we can solve this problem into basically our Dirac notation, that will be more easier by the using operators. Okay, so let us try to go for this particular. And if I am talking about operators, that means I am talking about raising and lowering operator. This is the thing. Okay, so let us try to go for this one. So the psi is given, and what is this particular psi? At t is equal to 0, psi x0 is given, and that value is equal to a and this 3 phi 0x or psi 0x it is given, plus 4 phi 1x it is given. And we have to calculate the value of a. So we can write it in form of ket also, and if we are writing something like this, then this value is a 3 0 ket plus 4 1 ket, and we all know that psi must be equal to 1. So then we have mod a square, 3 square plus 4 square is equal to 1. So a must be 1 upon 5. So if we are talking about the normalized function, then psi x0 is equal to 3 upon 5 phi 0x plus 4 phi 1x, 4 by 5 phi 1x. So what will be psi xt? So obviously this phi naught will evolve with time, this phi 1 will evolve with time. So what will happen? That value is 3 upon 5 phi naught x, and the energy associated to this one is equal to h cut omega by 2. So this value is equal to minus I h cut omega by 2 upon h cut, and plus we have 4 upon 5 phi 1x e to the power minus I, the first accelerated state has energy 3 h cut omega upon 2 and h cut here, and time is also there. So what will happen? This psi xt is nothing 3 upon 5 phi naught x e to the power minus I omega t upon 2 by 4 upon 5 phi 1x e to the power minus 3 I omega t by 2. So this is my psi t. Let us try to construct mod psi t square. So when we have psi t, then we can go for the psi star, and then we can construct mod psi t square. So what is my psi t? So we have already calculated my psi xt, and this value is equal to 3 upon 5 and phi 1 e to the power minus I omega t upon 2, sorry, this will be phi 0, plus 4 upon 5 phi 1 e to the power minus 3 I omega t upon 2. And what will be my psi star if I am talking about psi star t? That means 3 upon 5 phi 0 star e to the power I omega t by 2 plus 4 upon 5 phi 1 star e to the power 3 I omega t upon 2. And what will be your mod psi square? And that is actually mod psi xt square. So I can write this one. So if we are talking about mod psi xt whole square, then we have 4 terms. So don't be confused, there is a scalar product. This is just a simply multiplication between these two functions. So what will happen? 9 upon 25 mod phi naught square, this into this, plus 16 upon 25 mod phi 1 square, and you have the cross term. And when we have cross term, then we have 3 upon 5, 4 upon 5, and I can write it here actually, so I can use the proper space. So this value is equal to 3 upon 5 into 4 upon 5, phi naught star phi 1, and this value, this into this is going to multiply, then this value is minus I omega t, and then this into this is going to multiply, then 4 upon 5 phi 1 star phi 0, and this value, and also we have, sorry, so this value is 4 upon 5 into 3 upon 5 phi 1 star phi 0, and this value is equal to e to the power I omega t. But here we should also know that this function phi naught and phi 1 is a real function, so there is not any problem. So what we can go for that? This value is psi xt mod psi square, then this value is equal to 12 upon 25 phi naught phi 1, and here we will get I omega t plus e to the power minus I omega t, something like this. So what we can do, we can just multiply with 2, and we can also multiply with 2 here. So I am just talking about this one. So let us write the complete solution. So when we are taking this one as a common, then we have getting 9 upon 25 mod phi naught square, 16 upon 25 mod phi 1 square, and we can take it common, so that value is 12 upon 25 into 2, and you have phi 1 phi naught and cos omega t. So this value will be there. So what is your mod psi t square? Mod psi t square is equal to 9 upon 25 phi naught square, 16 upon 25 mod phi 1 square, plus 24 upon 25 phi 1 phi naught cos omega t. So this is my mod psi t square. Now we have to calculate the average value of x and average value of p on this particular state, that is yours, this particular state. So again, what I will do, I will play a trick and I will convert it into the Dirac notation, so that in form of number of operator and number kit, so that we can easily use this all property of raising and lowering operator, and we can easily solve this thing. So let us try to go for this. So what will happen? Psi xt. When we are talking about psi xt, then this value is equal to 3 upon 5 0 kit e to the power minus I omega t by 2, and we have 4 upon 5 1 kit e to the power minus 3I omega t by 2, and this can be a psi xt kit. And when we want to calculate the average value of x, then we have to find the average value of h cut upon, so this value is equal to h cut upon 2m omega That is average value of A plus A dagger. So we have to calculate this particular thing. So what will happen when we will get this particular average value of 0 on A and A dagger, that will be 0. Average value of 1 A and A dagger, that will be also 0. So only what will happen, only cross term is going to survive. So when cross term is going to survive, then what I will get? We will get this particular term, that average value of x is h cut upon 2m omega, or you can write something like this also. Let us write it completely. So that value is 3 upon 5, 0, x, 0. And because we can apply psi from both sides, and this will be 9 upon 25. 9 upon 25. Then we have 16 upon 25. Phi 1, x, phi 1. This exponential term will gone. And what we will get? We will get basically 3 upon 5, and this cross term will going to survive. So when cross term will be going to survive, so then what we will get? We will get 3 upon 5, 4 upon 5, and we have basically into 2, and we have 0, x, 1, and we have cos omega t. So this term is going to be there. What will happen? This term is going to be 0. This term is going to be 0 because we know that average value of x on any stationary state for the harmonic oscillator is 0. What is our duty? That we have to only calculate this one. So what is going to this particular term? So this is 24 upon 25. And this value, when we are going to calculate 0 and A plus A dagger, and 1 is there, and the dimension quantity is h cut upon 2m omega, that is cos omega t. So what will happen? This value is 1. So what we will get this x, average value of x, as a function of time, that is 24 upon 25. And this is your amplitude h cut upon 2m omega cos omega t. So this is our average value at after time t. And we can easily see that we will get at t is equal to 0, we have some particular value. And how we will get the average value of momentum? So when we will get the average value of, so this is my average value of position. So this value is equal to h cut upon 2m omega 24 upon 25 cos omega t. And we all know that average value of momentum is m into t average value of x upon dt. So what we will get? We will get m root under h cut upon 2m omega, and we have 24 upon 25 minus omega sine omega t, and we will find the exact dimension of omega, and that value is equal to m omega h cut is there, so by 2 negative sign is there, and 24 upon 25 sine omega t. This is my average value of momentum. So this is very interesting. And in this problem, they have asked that we have to also verify the Ehrenfest theorem. So when we are, how we will get the Ehrenfest theorem? So if we are going to write the Newton's law, what is this? So that is average value of momentum d upon dt is equal to 1 upon I, and we have average value of momentum with the Hamiltonian of the harmonic oscillator, plus we have del p upon del t. And we know that this momentum operator is not explicit function of time, so this value is equal to 0. And when we are going to calculate it, 1 upon I, and this value is will survive p, and Hamiltonian is p square by 2m plus potential energy, that is half m omega square x square. So we have to just go for half m omega square x square. So this will going to be calculated and we will get that minus m omega, and we have to take the average value. So minus m omega square average value of x. And we know that average value of x is this one. So we can get this one. That value is minus m omega square. Average value of x is equal to h cut upon 2m omega, and we have 24 upon 25 cos omega t. So this will be my this side. And when we are going to differentiate with respect to time, then what will happen? This sine will go into cos, so we will get something, same thing we are getting from there also. So we can just compare from both sides and we will get exactly dp upon dt. When we are getting dp upon dt, we will get exactly same thing. So yes, it is going to follow the Ehrenfest theorem, and which is equivalent to what Newton's law if we are talking about rate of change of momentum. So let us try to go for a last problem. Last problem is very simple. We have basically x psi xt. And what is your psi xt? Our psi xt is actually 3 upon 5, 0 ket e to the power minus omega t upon 2, 4 upon 5, 1 ket e to the power minus I 3 omega t upon 2. So if energy will measure, then what will be measurement? The measurement is equal to h cut omega by 2. So what are the possible measurements basically? So they are basically h cut omega by 2 and 3 h cut omega by 2. And what is probability of h cut omega by 2? Is nothing but 9 upon 25, and probability of 3 h cut omega by 2 is nothing but 16 upon 25. Even if at the time t is equal to t, because this is just a complex number, so this mod square is not going to change. So students, it's a wonderful question, and it is very interesting that how you are going to compare it with the classical system. This is very important. And it is also asked that when you will replace psi 1 to psi 2, then what is going to happen? When we are going to replace psi 1 to psi 2, then basically in a probability density part, here cos omega t is replaced by cos 2 omega t, because it is just about the energy difference between two levels. So this is just going to there, and it will be phi 2 and phi 1. But when we are going to go for the average value of x, then obviously this is very interesting, because we have to calculate phi 1 x, sorry, phi 0 x, phi 2, which is actually 0. So you can do it with yourself, but this is the complete information of problem 2.13 of TJ Griffith. Thank you.